Instead of tackling a huge topic today, we're going to do something a bit different. We're going to laser focus on just one single exam question. But this isn't just any question, it's a massive 12 marker on carboxylic acids. And we are going to break it down piece by piece to show you how to get every single point. So here it is in all its glory. Question 07, 12 marks, 6 different parts, and it touches on a whole bunch of different ideas. Now, I know it looks like a bit of a beast, but trust me, by the end of this, you'll see it's totally manageable. We're going to see exactly how every single mark is owned. Let's dive in. All right, part 1. The question kicks things off with the absolute fundamentals. It's basically asking, do you know how to name these things and write their formulas? This is the foundation for everything else that's coming up. Okay, so here's our first little task. 2 marks are up for grabs here, one for figuring out the formula for methanoic acid, and the other for putting a name to that second acid, the one with 3 carbons. Go on, have a quick think. What would you write down? And here are the answers, straight from the mark scheme. For methanoic acid, it's HCOOH. Now, here's a good tip. The mark scheme also accepts HCOO2H, which is really just a shorter way of writing the same thing, so don't let that throw you. And for the second one, that acid is propanoic acid. Just like that, 2 marks in the bag. Easy start. Let's keep that momentum going and move on to part 2. You can see how the question is building now. We're stepping up from just remembering facts to actually explaining a really core concept. What does it really mean for an acid to be weak? So the question is simple. Explain why ethanoic acid is a weak acid. This is a classic 2-mark explanation. It's not enough to just say something like, oh, it has a higher pH. Nope. You've got to explain why that is on a chemical level. Okay, so to get both marks, you need 2 very distinct ideas. The first point you absolutely have to make is that weak acids only partially or incompletely ionize when you put them in water. That's mark number 1. But here's the bit people often forget. The second mark comes from explaining why that happens. And it's because the reaction is reversible. It's in equilibrium. You need both of those points for the full 2 marks. All right, on to the next section. This is where the question gets a bit more practical and puts our knowledge into a real-world lab scenario. So I want you to picture this exact setup. You've got an open flask, you're doing a reaction, and it's all sitting on a digital balance. Now, this one's a 3-marker. We're mixing an acid with a carbonate. The second you see that combination, your brain should be screaming one thing: a gas is gonna be produced. The question wants you to explain what happens to the reading on that balance, and more importantly, why. And this just shows that 3-step thinking perfectly. First, what do you see? The mass goes down. That's your first mark. Second, what's the chemistry behind it? Well, you've produced carbon dioxide gas. That's your second mark. And third, what's the physical explanation? Because the flask is open, that gas just... Okay, we are flying through this. Part 4 now, and we're changing gears a little bit, moving into the world of reaction kinetics. This bit is all about comparing how fast two different acids get the job done. Right, another 3 marks on the line. The question tells us that methanoic acid reacts faster than ethanoic acid, and we have to explain why. And look at this. They even give us a huge hint. You should refer to ions in your answer. They're literally telling us what to talk about. So before we dive into the full explanation, let's just lay out the facts. We know methanoic acid is a stronger acid than ethanoic acid. That means it's going to have a lower pH and, as the question tells us, a faster reaction rate. This is kind of the groundwork for the perfect answer. And here we go, the perfect 3-step logic for all 3 marks. Step 1, you just state that methanoic acid is the stronger acid, or that it has a lower pH. Step 2, and this is where you use the hint, you link that to the ions. A stronger acid means a higher concentration of hydrogen ions. And finally, step 3, you connect it all back to reaction rates. More ions means more frequent collisions. It's a perfect chain of reasoning. We are on the home stretch now, I promise. For the final part of this question, we're taking a bit of a sharp turn, moving away from acids reacting and diving into the world of esters. Okay, this one's a nice simple 1-mark recall question. What do you get when you react ethanoic acid and ethanol? It's all about knowing that naming convention. And the answer is ethyl ethanoate. It's pretty logical if you think about it. The ethyl part comes from the alcohol, ethanol, and the ethanoate part comes from the carboxylic acid, ethanoic acid. That's a lovely, simple mark if you know that rule. Okay, here it is, the final mark of the entire question. We've gone from the name, and now we just need to be able to spot the right structure from a few different options. And that's the one you're looking for. See how you can almost see the 2 parts that made it? You've got the ethanoic part on the left, with its 2 carbons and the double bonded oxygen, and then connected over here on the right is the ethyl group with its 2 carbons. And that's it. That's our 12th and final mark. We did it. So we've broken it all down. We found every single one of those 12 marks, but let's just zoom out for a second. What was this question really testing? Why is it worth so many points? Let's do a quick recap. I mean, think about it. This one single question was like a mini exam all by itself. It tested your naming skills, your definitions, whether you could predict what happens in an experiment, if you could explain reaction rates, and even your knowledge of esters. It's a fantastic example of how all these topics you learn in chemistry aren't in little boxes, they're all connected. And that is how you deconstruct a 12-mark monster question. We've seen how these acids work and how they form esters, but their story is so much bigger than that. That same functional group is what makes an amino acid an acid. And amino acids, as you know, are the building blocks of proteins. So here's a thought to leave you with. You've mastered carboxylic acids. But how does that knowledge connect to the even bigger, more complex world of polymers and proteins?